So now that we have that natural log of x over x, if we let x approaching infinity, we get numerator denominator being infinity over infinity. That gives us indeterminate form. So remember, indeterminate form can either be infinity over infinity or 0 over 0. And once you have either version of indeterminate showing up, you can apply L'Hopital. So take the derivative of the numerator, get the derivative of the denominator, reevaluate. And if that gives you a real number, you know you're set. So 1 over infinity essentially going to be 0. 0 over 1 is 0. That's a real number, but that's not quite our answer because we've only taken care of that right side after we took natural log of both sides. So ultimately we want to solve for y. So now we do natural log of y is equal to 0, which is essentially y equals 1. We exponentiate both sides. E to the natural log of y is just y. Y equals e to the 0. E to the 0 equals 1. Okay, I picked these problems out from different publications as well as from different AP exams. I didn't bother changing the numbers, so the numbers are kind of jumping all over the place. But this is problems I picked out from Barron's BC practice test. So, and then over the course of this packet, I have just problems that I selected from older AP exams. So I would indicate where it's coming from as you go through their packet. 24. If I see two different families of functions, obviously we want to try u substitution first, but you can tell that x cosine x is not going to quite get us where we want to be with u substitution. And this is one where we want to involve integration by parts because we have two different families of functions being multiplied together. And this is, obviously we want to try u substitution first, but if it doesn't work, then our second option is IBP, integration by parts. And then within IBP, we would prefer, I think we always prefer tab method, right? If we can let that u value, if we can let that f value be our polynomial or algebraic, then we know that tab method is nice and easy. But if natural log is involved, then we're forced to have to make that f portion natural log, and then we got to go through the full integration by parts. We can't do this shortcut IBP, but it's good to know both ways. But I think if we can, we probably prefer that method. I can also work it out using IBP method so that you can see that they are going to match up, and it's good to practice through both. So. Okay, I'll work that out here.
That's what close.
Yeah, something about your conditions.
Okay, I see it's continuous.
I can't say.
Okay, I'll just.
But you have your condition there. Derivatives.
No, you do that. You sure? Yeah, well, this is why it's supposed to be plus.
You're supposed to do the antiderivative on the side.
Oh, yeah. So it's going to be derivative on the left side for tab and antiderivative on the right side.
There you go.
Watch your back go. You're not ready.
Oh, I do. Here's the four. You can't go to spot. Over. That's you do. You gotta divide it by two factor. Like so bad, but like fully.
Probably should, probably take some of that.
It's not, it doesn't do it.
And then once it comes in, it's under the downstairs.
No,
I'm so blind. I'm not really.
I'm still, I'm still on my system. That's it. Which makes sense. So, yeah.
And here's number 24, working it out using integration by parts. Integral of fg prime equals fg minus integral of f prime g. Here's my f, here's my f prime. G prime is cosine, g is sine. So here's my fg minus integral of f prime g. One sine x, sine becomes negative cosine. The two negatives cancel out, I get positive. So we can either go through that method or integration by parts, and we'll get the same answer. A little bit more tedious with integration by parts, but it's good to know both. Yeah, really short period. We'll work for 5 more minutes and I'll let you guys get your thoughts.
Oh, yeah, just. Well, first.
Like a lot.
Just use the formula. Because you know the max is going to be squared, so x has to go back to include that. Because that's the only max is going to be left with it. So just plug that in, so you get this, and you just plug the formula first. And then that's the last one. On this is it's also simple, like you're following to turn off. I have the plug. I use it for the notes. I get for it. It's like so. Oh, so it's like, oh, yeah. Oh, it's not. It's not. Good. That is just. My friends like that. Next. It's their seat. I told you. Yeah. No, my bad. Like chat. No, I'll never. What's the stuff in the way? Moving right. Just a shoe code. Right in the next one. So many such. You could do, and I'm going to use this here for 1 plus. That's not. My fingers open the time. Let's see. This is first. See what each was on. This one is. It's big.
Okay, you guys can call me, get your phones.
Yeah. I need to put it down. So. No. Wednesday, like it's like beginning at like 4 hours after the 30. And you go to bed, you guys can do this. Yeah.
How'd you wake up?
8.
Yeah. I woke up at like 4 because.
I don't know why. I didn't get wait. I knew about that. I was going
Last one.
And yeah, the tricky thing is that between -1 and 1
There.
are, so obviously your action is going to be positive, but why is such a thing? Negative 1, you're still getting y value positive. Positive, positive, still good.
So what is? Yeah, certain. I do know. It's based on that. So, yeah.
Into the box.
So if they give you an instrument, it's just that the FAA is. But if it's.
Then you set price.
Okay.
Well, no, I should be your thing. That's why I was like.
So you do the.
Let's send that there, right? That's all. That's when the most part. I know who you are. Only when they just, I know you. You're seeing your name,
No, I'm.
I took you on a dare. You need to question, bro. That was. Oh, why is it matters? Yeah, I just saw it. Honestly, it was Ryan. Exist.
Show me that one, yeah. Show them if you can. We're good.
Are you okay? You okay?
Are you good?
Yeah, I'm fine.
It's good. That's tomorrow. We can get them done.
That's lucky.
No, we have that, the homework stuff. We have the two.